This video is about solving trig equations and inequalities. This is AP Precalculus topic 3.10. If you appreciate this content, please give it a like. If you have not already memorized these 9 trig facts, pause the video and memorize this chart right now. Number 1. What are all values of theta on the interval from 0 to 2 pi for which sine theta is less than -1/2? First, we need to find where sine theta is equal to -1/2, and we can find the reference angle by ignoring the negative sign and asking the sine of what angle is 1/2. We have memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. By the way, a reference angle is the angle between the terminal side and the x-axis. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. In this case, we want sine theta to equal -1/2, so we will stick to quadrants 3 and 4, where the y value, and thus the sine function, is negative. We can think of pi as 6 pi over 6, so this angle in the third quadrant is 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. On the unit circle, the sine of an angle gives the y value, or the vertical displacement, of the intersection points. Since the sine of both of these angles is -1/2, this light blue line can represent a vertical displacement, or a y value, of -1/2. We are looking for the angles where the vertical displacement is less than -1/2. In other words, we are looking for the angles where the intersection point will fall below this light blue line. Since the domain is from 0 to 2 pi, we need to begin our rotation at 0 and then rotate around all the way back to 2 pi, looking for solutions as we go. First of all, do we have a solution right here at 0? We are looking for angles where the vertical displacement is below -1/2. This endpoint at 0 is not below the light blue line, so we do not have a solution right at the beginning. So we continue to not have any solutions as we rotate through this part of the circle. Notice that the endpoint is still above -1/2. Until we get to right here. At an angle of 7 pi over 6, the vertical displacement is exactly -1/2. This is still not a solution yet, because we want the vertical displacement to be below -1/2, not equal to. The solutions begin as we pass 7 pi over 6, and we will find solutions on the interval between 7 pi over 6 and 11 pi over 6, because this endpoint is below -1/2 between these two values. 11 pi over 6 will not be included because, again, the vertical displacement is exactly -1/2 at 11 pi over 6, and we don't want equal to -1/2, we want less than. I have highlighted this set of solutions in orange with open circles at the endpoints to indicate that 7 pi over 6 and 11 pi over 6 are not included. We can write this solution set in interval notation using parentheses to show that the endpoints are not included. We can also write this solution set as an inequality. We will use a less than sign instead of a less than or equal to sign to show that the endpoints are not included. Are there any more solutions coming? We haven't quite finished our rotation. So far, we have shown all of these solutions between 0 and 11 pi over 6. As we pass 11 pi over 6, the vertical displacement is again above -1/2, and that's not what we are looking for. So there will be no additional solutions between 11 pi over 6 and 2 pi. So this is it. For a free response question, it doesn't matter whether you record your answer using interval notation or using an inequality. but either one could show up on a multiple choice question, so make sure you are familiar with both. Number 2, what are all values of theta between 0 and 2 pi for which cosine theta is greater than or equal to radical 2 over 2? We need to start by finding where cosine theta is equal to radical 2 over 2. We can find the reference angle by asking the cosine of what angle is radical 2 over 2. We have memorized that the cosine of pi over 4 is radical 2 over 2, so pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 4. Since we want cosine to equal positive radical 2 over 2, we will stick to quadrants 1 and quadrants 4, where the x value and thus cosine are positive. The angle in the first quadrant with a reference angle of pi over 4 is pi over 4 itself. We can think of 2 pi as 8 pi over 4. So this angle in the fourth quadrant must be 7 pi over 4. On the unit circle, cosine gives the x value, or the horizontal displacement, of the intersection point of the angle. The cosine of both of these angles is radical 2 over 2. Therefore, the horizontal displacement at pi over 4 and 7 pi over 4 is exactly radical 2 over 2, represented by this light blue line. We are looking for the values of theta where the horizontal displacement is greater than or equal to radical 2 over 2. So we are looking for the angles where the horizontal displacement will be to the right of this light blue line. The domain is limited to the interval between 0 and 2 pi. So we need to start our rotation at 0 and then rotate all the way around and back to 2 pi, looking for solutions as we go. But again, we are starting here at 0. So do we have a solution right at 0? Well, the endpoint here is to the right of the light blue line. The horizontal displacement is greater than radical 2 over 2. And that is what we are looking for, greater than or equal to. So this counts. So we have our first solution right at 0. I'm going to go ahead and put a closed circle here to represent the fact that we have found a solution. As we continue to rotate, we find more solutions on the interval from 0 to pi over 4. Notice that the endpoint continues to be to the right of the light blue line. On this interval between 0 and pi over 4, the horizontal displacement is greater than radical 2 over 2. We have found our first set of solutions between 0 and pi over 4. Pi over 4 should be included because the horizontal displacement here is exactly radical 2 over 2. And we are looking for where the horizontal displacement is greater than or equal to radical 2 over 2. So pi over 4 should be included. Let's continue our rotation journey. So we have a solution here. As we rotate past pi over 4, we no longer have a solution because now the endpoint, the horizontal displacement, is less than radical 2 over 2. We are to the left of the light blue line. And that will continue to be true. No solutions on this entire interval between pi over 4 and 7 pi over 4. When we get back to 7 pi over 4, we hit another solution. Because once again, the horizontal displacement is exactly radical 2 over 2, and that's one of the things we are looking for. So 7 pi over 4 will begin a new solution set. And then as we continue to rotate between 7 pi over 4 and 2 pi, we still have more solutions. The horizontal displacement is to the right of the light blue line. We are at a horizontal displacement greater than radical 2 over 2. So let's highlight this remaining set of solutions. In interval notation, the set of all solutions is given by the interval from 0 to pi over 4 union the interval from 7 pi over 4 to 2 pi. Notice that in interval notation we use brackets to indicate that the endpoints are included. Whoops, I made a small mistake right here. I'm noticing now that 2 pi is not included in the domain. See the less than sign, not the less than or equal to sign that we have next to the 0. This means that 2 pi cannot be included in the solution set. So in interval notation, we show that the endpoint is not included by using a parenthesis. When you write the solution as an inequality, as I've shown below, we use a less than or equal to sign to show that an endpoint is included, and we use a less than sign to show that the endpoint is not included. Number 3, let f of x equal sine x. What are all values of x in the xy plane on the interval from 0 to 2 pi for which f of x is greater than negative radical 3 over 2? So we are looking for where sine x is greater than negative radical 3 over 2. We must begin by finding where sine x is equal to negative radical 3 over 2. We will find the reference angle by ignoring the negative sign and asking the sine of what angle is radical 3 over 2. We have memorized that the sine of pi over 3 is radical 3 over 2, so pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since we want sine x to equal negative radical 3 over 2, we will stick to the third and fourth quadrant where the y value, and thus the sine function, is negative. We can think of pi as 3 pi over 3 and 2 pi as 6 pi over 3. So this angle in the third quadrant is 4 pi over 3, and this angle in the fourth quadrant is 5 pi over 3. On the unit circle, the sine function represents the y value, or the vertical displacement of the endpoint of the angles, and the sine of both of these angles is negative radical 3 over 2. So this light blue line represents a vertical displacement of exactly negative radical 3 over 2. We are looking for where the y value is above negative radical 3 over 2. Since the domain goes from 0 to 2 pi, we must begin our rotation at 0 and then rotate around in this direction until we get all the way back around to 2 pi. Do we have a solution right here at the beginning, right at 0? Well, at this point, the vertical displacement is above the light blue line, and we are looking for where the y value is greater than negative radical 3 over 2. So this is a solution. So we begin our rotation with a solution. I'm going to put a closed circle to represent we have already got one. So now we continue to rotate, and we still have solutions happening because the endpoint is still above the light blue line. The vertical displacement as I rotate is greater than negative radical 3 over 2, all the way until I get to here. At 4 pi over 3, the vertical displacement is exactly negative radical 3 over 2. Should this endpoint be included in the solution set? I'm going to show that the endpoint should not be included because at 4 pi over 3, the vertical displacement is exactly negative radical 3 over 2. We are looking for where the y value is greater than negative radical 3 over 2, not equal to, so this cannot be included. But we had solutions all the way as we rotated from 0 until we got to 4 pi over 3. So we have a solution set. In interval notation, this set of solutions will look like this, and as an inequality, the same set looks like this. It is time to continue our search for solutions. Picking up where we left off at 4 pi over 3, we do not have a solution. As we rotate past 4 pi over 3, these are not solutions either. On the interval from 4 pi over 3 to 5 pi over 3, the vertical displacement is below negative radical 3 over 2. We are looking for where the vertical displacement is above negative radical 3 over 2, so these are not solutions. The endpoint of 5 pi over 3 is not a solution either, because the vertical displacement is exactly negative radical 3 over 2, but not greater than, so this is not a solution. But as we pass 5 pi over 3, we get into some more solutions. Notice that now the vertical displacement is above negative radical 3 over 2, and that's exactly what we are looking for. So I'm going to put an open circle here at 5 pi over 3 because that's not included. But then I will highlight these solutions. Be careful, should the angle 2 pi be included in the solution set? Well, at 2 pi, the vertical displacement is above negative radical 3 over 2, and that is what we are looking for. So 2 pi is a solution, and in interval notation, we will show that using a bracket. As an inequality, we will show that 2 pi is included by putting a less than or equal to sign. Here are all the angles where the vertical displacement, and thus the sine function, is greater than negative radical 3 over 2. Number 4. The function k is given by k of theta equals 2 sine theta. What are all values of theta on the interval from 0 to 2 pi, where k of theta is equal to negative 1? We are looking for where 2 sine theta is equal to negative 1. Let's isolate sine theta by dividing both sides by 2. This gives sine theta is equal to negative 1/2. We can find the reference angle by asking ourselves the sine of what angle is 1/2. Ignore the negative sign. We have memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine to equal negative 1/2, we will stick to quadrants 3 and 4, where the y value and thus the sine function is negative. We can think of pi as 6 pi over 6. So this angle in the third quadrant is 7 pi over 6. That's one solution to the equation. Theta is equal to 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. That's another solution. So we have theta is also equal to 11 pi over 6. So the answer is D. Number 5. The function f is given by f of x equals 2 tangent pi x plus 3. The graph of f is mapped to the graph of g in the same xy plane by a horizontal translation of the graph of f by pi over 2 units to the right. Which of the following is an expression for g of x? Long ago, we learned that a horizontal translation pi over 2 units to the right will show up as minus pi over 2 inside the function. So g of x will equal f at x minus pi over 2. We just need to take this expression, x minus pi over 2, and plug it in right here. To help you picture what's about to happen, you can think of f at x minus pi over 2 as f at smiley face, where the smiley face is x minus pi over 2. But for now, think f at smiley face. So we know that g of x is equal to f at smiley face. And we know that f at smiley face means plug in smiley face for x right here. So that gives 2 tangent pi smiley face plus 3. But smiley face is actually x minus pi over 2. So g of x is equal to this expression, and the answer is B. Number 6. In the xy plane, the graph of which of the following functions has a vertical asymptote at x equals 3 pi over 4? Let's begin with option A. Tangent x will have a vertical asymptote wherever tangent x is undefined, but tangent x is equal to sine x over cosine x. This expression will be undefined wherever the denominator cosine x is equal to 0. Cosine is the x value, or rather the horizontal displacement, on the unit circle. So the question is, where is the horizontal displacement equal to 0? Right here, we are 1 to the right, so that's the horizontal displacement. The horizontal displacement is equal to 0 right here at pi over 2, and then it will be again 0 right here at 3 pi over 2. Notice that the x value was not 0 at 3 pi over 4, which would have been right here. So A is not the answer. Consider option B. Tangent of x minus pi over 2 is equal to the sine of x minus pi over 2 over the cosine of x minus pi over 2. So we will have a vertical asymptote wherever the denominator, cosine of x minus pi over 2, is equal to 0. We can begin to solve this by solving for x minus pi over 2. So where will cosine equal 0? Well, we just saw that cosine is equal to 0 at pi over 2 or 3 pi over 2. So it's just a matter of adding pi over 2 to both sides of this equation. So we will have x is equal to pi over 2 plus pi over 2 is 2 pi over 2, which is just pi. If you take 3 pi over 2 and add pi over 2, that's going to be 4 pi over 2, which is 2 pi. On the interval from 0 to 2 pi, these are the two angles where option B will have a vertical asymptote, not at 3 pi over 4. Similarly, option C is equivalent to sine of x minus pi over 4 divided by the cosine of x minus pi over 4. Option C will have a vertical asymptote wherever the cosine of x minus pi over 4 is equal to 0. So we need to solve for x minus pi over 4, and we know that cosine is equal to 0 at pi over 2 and 3 pi over 2. So to find x, we need to add pi over 4 to both sides. Let's do 2 over 2 to convert these to like denominators. So if I multiply by 2 over 2 here and here, we are looking at 2 pi over 4 and 6 pi over 4. Keep that in mind. So we will have x is equal to 2 pi over 4 plus pi over 4 is 3 pi over 4. And 6 pi over 4 plus pi over 4 is 7 pi over 4. Option C will have vertical asymptotes at these two angles, and one of those angles is 3 pi over 4. So the answer is C. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.